community, going from community to premium. And I believe, yeah, let's do some intros first. So my name is Dominique. I am a solutions architect here at GitLab. We'll be joined with Claire, Florian, and Seraphine. Claire is going to take over the second half of the workshop, so you'll be seeing more from Claire later, and Florian is here to help out on the Q&A. Seraphine is our amazing demo architect who built most of this, so she's here to help us in case some stuff doesn't seem to go the way it should. And before we kick off, I would like to do a little poll because it helps us figure out what people's levels are. So if you could go ahead and answer these questions, it would be great to know which GitLab edition you are currently using. So looks like we already have a fair amount of premium users on the call. So we've got 6 more people that haven't responded yet. Give it a few more seconds. And the buzzy fly is back. I haven't spotted it yet. Okay, well, give it 5 more seconds and then we can close the poll. It looks like the majority of the people are already on premium. So just so you are all aware, the majority of what we'll be discussing today is going from community edition to premium, what that would look like. So if there is any, there's only a smaller delegation of users only of community edition, 1 person ultimate, and a couple of people not using GitLab at all. So it's a good mix, although I am hoping that for the folks on premium, this workshop will still be of interest. So hopefully we can, well, I'm going to guess that the reason why you're why you're here today is that you're not yet using CI. Maybe that's a possibility. Feel free to pop it in the chat, but hopefully you'll be able to get something out of it today as well. Okay, so yeah, so we've met the team, and I believe it's now time to start the workshop. So today we are all new team members working for a startup that has built a popular new racing game called Tanuki Racing. The company is currently using GitLab CE, Community Edition, but is planning on upgrading to GitLab Premium to take advantage of the advanced CI/CD features. And you have been tasked with learning about the different pipeline capabilities. So let's go ahead and spend the next small bit of time. I say small, but it's always a bit of a challenge, but getting everything set up. So we need to get our feet under our desk. We need to get comfortable on our instance. And in the next section, I'm going to help you get your lab environment set up. Again, if you run into any problems, please put them in the Q&A section so the team can help you. Okay, so you can do a couple of things. You can either scan the QR code. You can, I would like you to go to gitlabdemo.com and then redeem your invitation code. The invitation code is shared in the chat already. Thank you, Florian. And once you have redeemed the invitation code, you need to log in and then search for your test group. So I'm going to go through this shortly. So I will show you how to do it momentarily. But you will need your GitLab ID. If you don't know this, open up a new tab with gitlab.com open, and then you can find your ID when you click on your avatar. So your ID will be what comes after the @ Seraphine, did you want to say something?
Oh, sorry.
Apologies. Okay, so GitLab ID without the @ and then as soon as you go to the gitlabdemo.com, you get this little box, hit the invitation code. You can click the sign in button to sign in with the credential that will generated for you, and otherwise you can paste this into the box. And again, provide your GitLab username. And then once you click provision training environment, then you get a screen like this. And then you can go to my group to, well, see my group. If you want, you should be seeing a group, the test group already. Don't touch it yet. Just make sure you have access. We'll go through all of the bits and pieces as it comes. So take your time. If you do get a 404, you might not have been signed in. So make sure you are signed in with your correct GitLab account. All right, so getting back to the group, let me just show you real quick what is going on. So go into gitlabdemo.com and then copy the invitation code. Then provision. Is it all big enough or does anybody need it to be a little bit larger? Anyone can say anything? Tiny bit larger. Okay. Tiny bit larger then. I also have bad eyes, even though it's like a massive ultra wide screen on this desk. um, yeah, but we're here to make sure everybody's here for the ride, right? All right, so provision training environment, click the big blue button. My GitLab username is GitLab Electronique. Fun fact, that's also on my arm. Well, not without the GitLab, obviously, but that's the that's been on my that's been my alter ego for a long time, long time. Right, now we have this little uh page that it says you've got your GitLab credentials. And then once we have this page open, you go to my group and then you'll be greeted with your group. So we have a test group. This should look different. So it's a randomly generated name, but you should have the workshop project in there already. Should be pre-provisioned. If it hasn't been in there, if it's empty, give it a moment, maybe refresh the page. But if it still isn't there after a couple of minutes, then let us know, and then we can organize this for you and tell you how to get access to this project. But you should have been provisioned the project already. Okay, so hopefully if everybody can give me a thumbs up response if you're okay. Otherwise I am going to carry on with the rest of the content. So you will have plenty of time to do this again. So there will be the next section will be about maybe 10 to 20 minutes of stuff that I'm going to say, a couple of slides, and then we'll go into the hands-on lab section. So I will show you a bit more about the rest of the agenda, but let's talk a little bit about the key differences of Community Edition versus Premium. Right, so for CI/CD, we have at a high level, we have categorized these features in three main bits. So either we have faster code reviews, we've got advanced CI/CD features, and then the enterprise agile delivery features. So we're gonna test some of these out in the hands-on section of this workshop. Obviously, there's another tier. We have ultimate as well. So I think there was one person who was ultimate, but if I read the chat correctly, they might be on dedicated, which is fine. But from a subscription perspective, you obviously have the Community Edition, Premium, and Ultimate. But we're going to test out some of the features that you see on your screen in the labs today. So what comes to mind when you think of better code controls? You could probably think of better collaboration, code being reviewed by experts in that domain, and also having an idea of who they are and when they did something, protecting the default branch by having rules put in place to prevent untested or unauthorized merges, and finally, what security and compliance steps can be put in place to prevent being exposed to risk. I've highlighted some of the bits and pieces here. There's been some highlights here about the advanced CI/CD and agile delivery features. So I've got file templates, external repositories, merge trains, and I think the majority of this is going to be something that we discuss. So if you wanted a more detailed overview of these, we have a dedicated page for this, as you can see on the top of the screen. Feel free to go to that page at your convenience and see what else you're missing out on. To be fair, it's always nice to like give out or add new features to things, but it also has to be relevant and useful, right? I'm always I always say that I'm in the business of like helping people and not necessarily to chuck features over the fence. Rightio. So, with that out of the way, I think it's time to start with our first lab. Uh, we are working on the Tanuki racing game, and that's why we're working with labs. So let's discuss pipeline execution order, allowing for job failure, and caching of artifacts. So this is the workshop agenda. We've just set up our lab. Now we're going to work on our starting pipeline. After this hands-on section is completed, then we're going to have a really short break. And then after that, Claire is going to take over and take you through the rest of the hands-on bits. Right, so in the labs, you are a new CI/CD developer, and the product manager has asked you to test some of the different types of pipelines that are available in GitLab to figure out what suits our needs best. So the first task we get is to get a simple starting pipeline up and running, and then we'll be working through some more advanced topics from there. So before we do this, let's refresh some of the basic CI/CD concepts. So pipelines are the top level component in CI/CD. Pipelines comprise of jobs, which define what to do, and stages, which define when to do them. Within the job statement, we have script, before script, and after script. These are important, especially when you have scripts that depend on each other. Script is the only required keyword that a job needs. Without it, a job wouldn't have anything to do. The before and after scripts are optional. They pretty much do what they say on the tin. So before script runs the script statement, but in the same shell. Its main purpose is to execute steps that are necessary in order for the script statement to run properly. And the after script runs after the script and then are executed in a separate shell. So the after script return code does actually not impact the job success or failure. So some examples would be use the before script to install the AWS CLI with scripts and executing AWS CLI commands. Or when you create job artifacts, you might want to parse the results of the artifacts after you're done. Or you can use the after script for cleanup. So within a pipeline, a job is only evaluated as a pass or fail based on the exit code of the regular script statement. I'll have a sip of water. If I'm going too fast, by the way, please let me know. Feel free to just say slow down in the chat or something. Well, we have another couple of polls throughout the session to ask you some questions, but also ask if the pacing is right. But if you feel like it's going too fast, please just tell me. Right. So let's talk a little bit about pipeline execution order. So by default, each job in each stage get executed in sequence, but we can manipulate the execution order to help speed up the pipeline completion in a variety of ways. So as you can see at the top here, the initial state of the CI/CD execution, the jobs in the test stage will execute once the job in the build stage are completed. You do have the freedom to adjust the execution order based on your needs. So just something about the graph you see a screenshot of here. In our pipeline tool, we are making use of directed acyclic graphs, or DAG, which helps visualize your pipelines. This particular example is pretty basic, but you can imagine on the GitLab.com project that we have over 100 jobs that are all intertwined. So it's really helpful to have a visual of how your pipeline runs when building out complex pipelines. So if you want to adjust the job execution order, you can use the needs keyword. By default, pipelines run sequentially. So in the example on screen, you see that the code quality step has an empty needs. If you put needs in with an empty value, it will run as soon as the pipeline gets kicked off. So some of these tests can take a while to run. This can greatly speed up the runtime of your pipeline. Using needs can be way more powerful than this, though. You can specify dependence on another job. For example, if you're running a dynamic application security test stage, you can make that dependent on the build app being created first. Let's have a look. What else we have? So, since GitLab 14.2, you are able to use stageless pipelines rather than specifying build, test, security stages. You can use the needs keyword to specify dependencies and let that be in charge of the execution order. It's quicker to write too, apparently. Right, so let's talk a little bit about GitLab runners. So a runner is the application that makes running pipelines possible. There are a bunch of different types you can use, and they can be scoped on the project level, a group level, and shared across an entire GitLab instance. I am pretty sure that my wonderful Q&A team are able to share any links to documentation in the chat if you want. But for the purposes of this workshop, we don't really have to worry about it. So we have a shared runner set up on the group we'll be working from in the lab. But please bear in mind that the runner will run the pipeline from a queue. So depending on how many people hit run at the same time, you might have to wait a couple of seconds before your jobs gets kicked off. So the way you configure your runners can be as flexible as you need. Some of the most used config options are listed on screen here. You can account for timeouts, you can tag runners so they only run specific jobs or are executed in a certain location. Somebody still has a raised hand. I'm not sure if that is on purpose. If you did have a question, Yuli, I think I hope that I pronounced that correctly, but if you did have a question, please put it in the Q&A section. So I'm gonna just lower your hand because it's giving me a pop-up in my screen. But if you have a question, please feel free to open a question in the Q&A. Right. No, Christian, you should not be editing code yet. So what we're doing now is we're going through some of the content, and then afterwards, you're going to get some time to do the hands-on lab by yourself. But I will be doing everything on screen as well. So feel free to sit back and enjoy the ride until you go on the hands-on bits. And welcome. Right, so let's GitLab Runner implements a number of different executors that can be that can be used to run your builds in different environments. For example, the shell runs commands as if you're writing them into a terminal, or command prompts or PowerShell. We've got Docker that runs jobs on Docker images, and even though Docker deprecated Docker Machine, we actually maintain a fork of GitLab Runner for GitLab Runner that we maintain a fork of Docker Machine, so Docker Machine users can still use that if they are relying on the Docker Machine executor. You can also use the Kubernetes executor to use the Kubernetes clusters for your builds. The executor calls the Kubernetes cluster API and then creates a pod from each CI job. If you want to know more about this, feel free to refer to the runner executor documentation. Thank you, Claire. Okay, so once we've got the method of running your jobs out the way, now it's time to talk a little bit more about how to speed up your pipeline. So what you can do is use caching to leverage. You can leverage caching to speed up your pipelines. So, well, basically what it does is that a GitLab runner will take the content you've marked for caching and then stores it in an S3 bucket, which is pretty helpful if you, for example, are using I don't know, some node modules, for example, that can take ages to load. And by caching these, you can save yourself minutes, which is a long time if you are running pipelines pretty much on the regular. So why would you cache? So you can share downloaded content between jobs, even across different branches in a project. You can store code dependencies so you don't have to wait for them to load next time, and basically just increase the pipeline speed even further. So next, I'd like to clarify when best to use either caching or artifacts. The concepts may seem to overlap because they're both used for sharing content between jobs, but they're actually fundamentally quite different. So when a job doesn't rely on the output of another job, but would be sped up by having access to it, you can use cache. But when a job is dependent on the output of a previous job, artifacts are probably easier to use. So there's a link to a blog post with some more information. We'll share out the deck afterwards as well if it's not been shared already, but the link to that should be in there as well. Rightio. So let's talk about allowing for job failure, which is helpful. We can use the allow failure keyword with a value of true on the job. So when it fails, the pipeline will still carry on. You can allow the code quality or unit test or something to fail and the pipeline will still carry on. So somewhere throughout the workshop, some jobs are designed to fail. Just let it happen. That's okay. It's if pipelines can fail, it's okay, or at least pipeline jobs. So yeah, so the reason why we want to do this, for example, is that sometimes you just if you don't leverage allow failure and every single job is required, and there's one job that always fails and having to run the whole thing again it takes forever. Like you want your pipeline to run. So, all right, let's talk about rules. You can use rules to include or exclude jobs in pipelines. Rules are evaluated when the pipeline is created and then evaluated in order until the first match. When a match is found, the job is either included or excluded from the pipeline, depending on the configuration. Rules accepts an array of rules defined with what you see here on screen, and you can combine keywords to create more complex rules as well. So let's go over a couple examples. Let's take a water. So if there are cases when you do not want a job to run, you can exclude jobs from pipeline by using when, never. You're probably going to want to include this with a rules evaluation as part of an if statement. On its own, the job would indeed never run. Computers are smart like that. You can configure a job to be manual by using when manual. In case of these, in the case on screen here, test B has allow failure set to true. So it will still pass, and the deploy stage is waiting for a human to click play, basically. You also have the option for manual execution, depending on rules. For example, if SAST fails, make next job manual or something like that. So what if you want to delay a job run? You can set a rule for that. In the example on screen, this job will be created only when the pipeline is merging into your default branch. As you can see, it will start delayed in 3 hours and it's allowed to fail. The timer on the delayed job starts ticking immediately after the previous stage has completed. And lastly, before we go into our first lab challenge, this overview is quite useful to help understand the order of variable precedence from highest to lowest. So I'm not going to read out everything on screen. It's just, it's long. If you can read yourself, it's not really nice. Right, so now we are going to move on to the hands-on portion of this particular lab. So what I want you to do is navigate to your Tanuki Racing group and then go to courses, workshop, and then CE to premium to pull up the instructions. So my test group is over here. So what you want to do is click over here into the project, then go to courses, workshops, and then CE to premium to find your instructions. The first one, we are going to go through this together. I am going to give you 6 minutes. Yeah, 6 minutes to do it yourself first. And then after 6 minutes or something, or maybe 10 minutes. Let's do 10 minutes. Do 10 minutes. After 10 minutes, I will. Is that useful? No. How about this? I'm going to do it first. I'm going to do it the other way around. Sorry. Normally, I prefer it to give you some time and then show you how to do it. But what I'm going to do instead is I'm going to do it first for you so you can see how it should go. And then you have time to catch up if you want. So feel free to either follow along or sit back and wait until you get the moment to do it yourself. So it shouldn't take too long. All right, so let's go through the first execution, allow order fails caching markdown file. So what you see here is I've duplicated the tabs. So I'll be working from this one, but this is where I'll read the instructions. So I'll be going back and forth between the two. So introduction. This challenge is going to walk us through the step of importing our CI/CD pipeline project and then achieving a faster and more flexible pipeline. So, step 1, creating a simple pipeline. Now that we have our project imported, as you can see over here, we have our project over here. Tanuki Racing is here. We are going to take a look at the GitLab CI YAML file. There's a couple of ways of doing this. You can either go to the left sidebar menu and click into the actual file in the repository, but I always prefer doing it by going to build and then pipeline editor. So if you go to build and then pipeline editor, you can see the document or the file, and you also immediately make changes if you want. So we are going to be working from this particular file the most in this whole lab. So we're working from here anyway, so I figured that would be useful. Okay, going back here. So we've got the file. So let's have a little look at what we want to check now. So we've got the pipeline editor. As you can see, we've got two stages here, build and test. So the build stage has a bunch of things in there, before script, script, and after script. And then we've got test that only has a script. And it's taking this image. And there's a bunch of variables there. All right, so we have looked at that. So we see in the test job, we want to use an after script keyword to echo that the job has completed, that the test is completed. So what we're going to do is we're already in the pipeline editor, but we want to add an after script to the end of the test job. So that's this bit over here. So go back to the pipeline editor. We've copied the bit of instructions from the instructions, and then we're going to paste it in exactly over here. This is not in the right place. Hold on. It's not in the right place. Spaces. There we go. So we're not pushing anything. Please, if you are following along, do not commit anything until I tell you to. Very important. It's until the end of this whole section we're committing, but we have so much to commit. And every time you commit, a pipeline will kick off. And I don't want to do that yet in the interest of time. So please do not commit anything until I tell you to, or until the instructions tell you to, which is at the end of this section. Okay, so we have added the after script to the test job. So as we can see over here, let me double check. Let me double check here if that is correct. And that seems to be the case. Okay, you can see here as well, it will check for your pipeline syntax to be correct, which I think is also a very useful feature. But yeah, so whenever you change anything, you can see as you type if something is working or not. Okay. So I've also been told that you are also able to see all of the instructions in the issues, but we'll get to that. We're here now anyway. Is everybody at the same point as me, or yeah. So I think the reason why Seraphine just kindly reminded me that that is the case, let me just quickly duplicate this so we know where we are. The reason why people use it why there's issues in here is that you can tick boxes, or you should be able to tick boxes, but there's yeah. Maybe Seraphine can
It's just easier. You have all the steps in one place in the issue, and you can finish that, move it, and then move to the next one instead of going through the repo to find the tracks.
okay. I was already late. Sorry. Yeah, I mean, there's multiple ways that lead to Rome, but yeah, if you haven't started it already, you can also do it from the issues. Sorry. Um, let's just from here then. Okay, where were we? So we added the after script. The new test job looks like this. And then step 1.4 says, do not commit. Please do not commit until I tell you to. I said that a couple times already. I keep on saying this because I have on many occasions also accidentally clicked the button. So it's, it's don't commit. We've got more stuff to add. So in its current state, the pipeline stages run in sequence, but we have been tasked to improve how fast our pipelines are completing. So in order to achieve this, we're going to change the execution order next. So as I mentioned, the stages in the pipeline run sequentially, and the job within each stage will run in parallel. if there are enough concurrent runners, but that's fine. So if we want to a job in a later stage to start earlier than the stage that it's in, we can use an empty needs keyword to change to kick it off immediately. Right, so we want two jobs from different stages to run in parallel, and we're going to use the needs keyword in our CI YAML. Let's have a look. So we're going back to our pipeline editor, which is over here. Right now, we only have the test job that will run during the test stage. So we're adding a new job below the test job called superfast test job. And this will kick off at the same time as the build stage. But the old test job will still execute in the test stage. So copying this to our clipboard because that's quick. And after the test stage, paste that in. That looks good. So we've got test, stage test, and we've got super fast test, stage test. So we've got two jobs in our testing stage, but because we've specified the need keyword to be empty, it will kick off at the same time as our build stage. Let's have a look. Where are we now? All right, again, do not commit yet. We still have some additional stuff into to add in here. So step 3, we're going to now add some rules and making sure that we allow to fail. So as part of the brief, our product manager has asked us to implement some logic to skip unnecessary jobs, as well as allowing certain jobs to fail without affecting the overall pipeline. So to achieve this, we are going to add some rules and then allow failure keyword to our pipeline. All right, so let's start with a basic one on a test job. Let's assume we only care about this job executing if the commit branch is the default branch. So when you're committing something to main or to your default branch. So let's add this rule definition to the end of the test job. So that will be here. Let me just quickly have a peek. Yeah, I think that's correct. End of the test job. Oops. Now, okay, so we added this. So let's make sure we allow the super fast test job to fail so that the rest of the pipeline will still continue. So we are replacing this whole portion within the test job, in the super fast test job, with this to make it fail. I'm seeing loads of questions, but there are I'm even though I know the answers, I'm gonna let the Q&A team handle that. Because otherwise we're gonna be stuck here forever. Because I like talking. Right, we're skipping this whole bit, the script bit with exit 1. So we are where did we go? Script bit is this bit. Just a second bit. I wanna That's still correct, thankfully. Okay, so what if we also wanted to allow failure on the job without affecting the pipeline? So we are add this rule to the end of the superfast test job. So copy this again. I'm going back to my superfast test job. Make this space go away because that doesn't look nice. And at the end here, I am adding this. Some rules. So again, do not commit yet because one last step to include, and that's step 4. So lastly, we're going to improve the pipeline speed by using caching. I promise we are going to commit this after this step is completed. Okay, so a cache is one or more files that a job will download and save. So subsequent jobs can use the same cache and doesn't have to download the same files again. So this helps with quicker execution. So lastly, on the theme of improving our pipeline speed, we are using, we're going to add caching. So we're going to add caching to the Ruby and gem file log so they don't have to be pulled in every time. Did I miss something? Did I put it in the wrong place? I don't think I put it in the wrong place. Did I add this? We'll check it in a moment. All right, so the cache goes under the image definition. That will be all the way over here. So this is what we should have. Super fast test. Oh, okay. So I did put it in the wrong place. I put something in the wrong place. Come on, let me just do the sneaky way and just copy it from here. So this is what it should look like. And I did copy it wrong, but that's on me. So there's just another example of make sure you read everything. If I am doing it wrong and I do this every day, then, that's, make sure everything is okay. So now I think it's finally time to commit all our changes. So we are going to provide a suitable commit message, as you should if you do this often, if you do stuff with code. The only thing that we are going to do is commit to our main branch, which is usually a what's the word? A little treat, because usually you shouldn't be committing into your main branch directly. That's at least not the best practice in the wild. All right, so let's have a look. Let's copy this whole bit because that looks like a suitable message to add to our commit. So put it in here because update YAML file is not necessarily a very suitable message. So optimize pipeline by adding a cache, branches main, commit changes, boom, and we are off to the proverbial races. Let's have a look as well. So now we're gonna have a little I just kind of want to see the pipeline go. So we are going to pipelines and we can see that now something is happening. So if you go to pipelines over here and then you click the long number over there, then you can see the pipeline go. If you want to see each specific job, then you can click into them to see more interesting things. But you can see that the super fast test job has kicked off at the same time as the build job, and the test job is neatly waiting until the build job is completed. Okay, so yeah, that's done that as well. And I think with that, I am now going to give you, let's say 5 minutes to catch up and have a little break. And then it's time for Claire to take over. So I am going to put this on screen, 5 minute break. We'll be back here well, if everybody is roughly in the same time zone. It's at the moment it's 1:45 here. So we'll get back here at 10 to. All right, feel free to catch up, maybe have a bio break, and I will see you shortly.
Okay, so as I said earlier in the call, I'm Claire Marie. I'm going to be taking over from Dami for the second half of this. I am just going to share my screen here. And in the meantime, Helena, could we run the poll question, please? Oop, there we go. Okay, it looks like most people are saying it's just right, and then the same amount of people are saying it's too fast or too slow. So get your votes in, folks, if you have an opinion. I don't know if I can talk as fast as Dami, to be honest, so we'll and I definitely don't have as sing-songy of a voice. Okay, so got a fair amount of responses in. I'm gonna go ahead and end the poll on this one. Yep. Okay, cool. Um, Sorry, just getting my chat set up, folks. During the break, I had a Chrome crash moment, so that was really fun. So I'm just getting all my windows in place. Um, all right. So for lap two, we're going to be talking about code owners, approval rules, and merge requests. At this point, after lap one, you should have a pipeline running with execution order, allowing for job failure and artifact caching. If you are still behind, feel free to ask in the chat as you'll have access to this workshop for the next 2 days to finish up. Um, yeah, okay. So, lap two, after demonstrating your simple pipeline to the team, they were very impressed and asked if you could enhance it by implementing code control, further speeding up job execution, and adding a mechanism to ensure the default branch always remains stable and green. You decide you are going to show off your skills and show how you can add code owners, approval rules, and caching to your pipelines. So we're going to have a brief overview of code owners, approval rules, and caching, and then we're going to do the hands-on exercise. To start off, code owners. Code owners is a handy feature for designating domain experts for areas of your code base. So code owners allows you to assign team members responsible for specific files in a project or folders. These team members are auto-assigned as approvers for merge requests that touch these relevant areas. I find this feature is especially useful in contexts like open source or when working in an unfamiliar repository. For instance, GitLab, when someone makes a community contribution, our code owners get automatically assigned to review it, rather than the contributor needing to decide which employee at a company of over 1,000 should review their suggested change. Thank you very much for the voice comment. As an American living in Europe, it's always nice to hear. Merge results pipelines. So these are a special kind of pipeline that run on the results of the source and target branches merged together. It merges your changes with the target branch to detect any errors or changes that might be green when testing on your source branch, but break your target branch before merging. Your target branch will usually be your default branch if you practice trunk-based deployment. So GitLab does this by creating an internal commit with the merged results. This commit does not exist in either of the branches, but it can be viewed in your pipeline details. And we're going to see this shortly in the hands-on section. So last thing for this section is going to be approval rules. And approval rules define how many approvals a merge request must receive before it can be merged and which users should do the approving. So this probably sounds very familiar to code owners, but I like to think of it this way. You should use code owners to ensure the group maintaining a specific file or feature are automatically assigned to review it. And you should use approval rules to assign users or groups responsible for specific areas of oversight. So like a security team might be an approval rule that you have. We'll get a chance to see the difference between the two features in the hands-on section. And with that, we are going to, is there any reason other than as a prerequisite for merge trains to use merge results pipeline if the repo is already configured to enforce semi-linear history? Lars, if you want to ask that in the Q&A, or if other people want to discuss that in the chat, that could be a good way to solve that. I'm going to stick with following the the lap for now, and maybe we can get to that afterwards. So if you go into your project within your test group that was previously provisioned to you, and go within courses, workshops, CE to premium, and then code owners, approvals, merge request results, rule something after that. That's going to be where you're going to find the instructions for this section. So I'm going to create 2 tabs. First thing we're going to do in this section is we're going to go and create a merge request approval rule. So if we go to settings, merge requests, and then merge request approvals. Here we go. We're going to add an approval rule. We're going to set the name as DevOps, target all branches, and set the required number of approvals to 1. We're going to add my colleague, L. Stucker. Why isn't he showing up? All right, we're just going to add me. And then, or I'll add someone else. Let's go for Tim. And then you're going to go ahead and save the changes. So now that we have the approval rule configured, we're going to set up the code owners, and then we're going to see those in action. So for the code owners step, we're going to navigate into our repository, because this is actually controlled within a file within our repository. From our repository, we're going to edit from our web IDE. The web IDE is a really handy way to make like quick edits if you don't actually need to go down all the way into Visual Studio Code, and you don't need to necessarily commit locally first. For instance, I use this a lot of the time. So from here, what we're going to do is we're going to create a new file at the root, and it's going to be named code owners. Okay, once we have code owners file, you are going to navigate that you want your GitLab ID. So replace that with whatever your ID is. And then we're going to click the source control button on this left side. And we are going to push to main in this case, but I just want to have a note that later on in the lab, we are going to be using this to push not to main. And in that case, what you're going to do is create a new branch and commit with this little side thing. But for now, we are just committing and pushing to main. So now there's going to be a pop-up at the bottom right of the screen, and we can go look at this project from here. If we navigate into build pipelines, we'll see that a pipeline kicked off for that because we made changes to our project. So now we're going to make a change to the README file, which the infrastructure group, which is me in this case, controls. So let's go back to our IDE and navigate to the README file. And then at the top, I'm just going to make a little change. And there we go. So now it becomes important that we do not click push to main. Now we need to create a new branch and commit. You'll notice if you leave it empty, it's going to auto-populate a branch name, which I'm going to choose to do. And I'm going to press enter to confirm that. Now, a new pop-up will appear at the bottom right-hand corner of your screen. You can click the Create MR button, and that's going to create a merge request associated with the branch you just created. So the only change we need to make on this merge request creation screen is, oh, actually it's already checked, but just make sure that the delete source branch when merge request is accepted is checked. Then we are going to create the merge request. So after this all generates, you're going to see that the merge request is blocked. And it requires one approval from our DevOps thing. Now, the reason these are optional is because I am the owner of this project. You are also all the owners of your projects. If you were not the owners of your projects, these would be required approvals. Part of the reason we didn't go ahead and step that up so that they would be required users or required approvals in this lab is then we would have to go and unchange everything for you to do future parts of the lab. So just a note on that. So it asks us to disable the approval rule. I don't think we really need to, but let's go ahead and disable it just to go through the exercise. Or at least I don't need to, but that perhaps others' permissions are different because they are not a GitLab employee. But anyway, whether or not you need to do this, we are going to go and disable the merge request approval rule by going here and just deleting the approval rule. We're going to leave the merge request that we had just created open for now. And our next step is the merged results pipeline. So the first step we're going to do here is we actually need to enable merge results pipelines. Because remember, we talked about how they're a special kind of pipeline that need to be enabled. So the setting is right here. If you go to settings, merge requests, and then the merge options here, you can just click enable merge results pipelines. And then if you scroll down, click save changes. If anyone is lost at this point, please, post in the Q&A, or maybe give me a thumbs up if you are following so far. Concerned that I have seen no thumbs? Okay, good. I have a thumb. Excellent. As long as one person is following, we'll carry on. Okay, there we go. Lots of thumbs. Excellent. Okay. It's not a merge train, it's a thumb train. All right. So now what we're going to do, is the merge results pipeline. Now that we have enabled it, let's go back to the pipeline editor. So we get to that going to build pipeline editor. And we're going to add a workflow keyword under the stages. So this workflow keyword will affect the entire pipeline as opposed to a single job. And then we are going to remove the super fast, the super fast test job from here. And the YAML, if you don't want to make those small changes like I did, you can copy and paste the full, you can copy and paste this full block here. To clarify, has it been okay for people that I haven't been showing the instructions on my screen? I've been looking at them on a different screen, but I can tab back and forth if that's helpful for people. Just let me know. anyway, so yeah, you can copy that block of code. And then we're going to commit this directly to main. And you can put in a cute little commit message like this and commit your changes. So interestingly, there's not going to be a pipeline that runs right now because we've actually told the workflow that it's only going to run when the pipeline source is a merge request event. And because we just committed to main, that is not a merge request event. So now let's actually test this out with a merge request. On the left sidebar, let's go again to, you're going to go to code repository and open your web IDE. I already have this open here, but I'm on my branch. Do I want to be on the same branch? Yeah. Okay, I'm actually gonna, yeah, so go to web IDE. This is maybe a roundabout way to do it, but we are going to add a block of code to the build job. So our build job will now look like this. And then we are going to create a new branch, so not using the one that we looked at before. And we are going to commit once again. We're going to create another merge request from that little pop-up that's going to open on the bottom right corner of your screen. And then from here, we want to, we can just go ahead and create the merge request. I don't think there's any changes we need to make. So give it a little bit of time to load. But soon we're going to have a merge request pipeline, probably. Oh, uh-oh. What have I done? So what I'm going to do here is copy the entire block of YAML code from the instructions again, because I've probably just made a little error. And then, sorry, and then go ahead and replace that build job again. Sorry, I am scrolling all over. There we go. Okay, so I will go ahead and validate this pipeline. Ugh. Seraphine, let me know for the indentation of build. Oh, okay, gotcha. Let me look at that. Thank you, folks.
Yep.
There we are. Thanks, team. Appreciate it. That should work now, but let's try again. Pipeline did not run. Well, okay, so it doesn't run here because we only run on merge request events, so that makes sense. We can go ahead and commit those changes to that branch. Sorry, we got a little lost there, folks. And then we'll go back to our merge request that we had just created. So yes, now we have a pipeline running, thank goodness. And once the pipeline is complete, oh, was the build thing? Okay, well, it's possible I have messed up even more tabs, but I think for the purposes of this exercise, it should be fine. Don't be like me, folks. And yeah, once this build is complete, we can actually set it to auto merge upon completion. And this is running a merged result pipeline. I'll go ahead and set that to auto merge. And if we go ahead and look at the pipelines tab, don't look at these my shame. You can see that there is a merged results tag that's been applied to the pipeline so that you can actually tell which types of pipelines are being run. Okay, so now we're kind of just going to wait for this pipeline to finish running. I don't know that we actually need to wait for it to finish for the lap to conclude. And indeed, I'm not sure I want you guys to watch this finish in case it fails. So I'm going to give everyone a couple minutes to finish up this exercise. Maybe give a thumbs up when you are done this part, and then we can move on to the next section. Yes, as admin of my demo group on GitLab.com, I frequently am deleting broken pipelines. The thing about being a solutions architect is you spend a lot of time building things that you haven't necessarily built before. So there's a lot of trial and error. Okay. So lap 3 is going to be talking about merge trains, and this is going to be associated with the merged results pipelines that we talked about in the last section as well. So you have become the pipeline superstar. Congratulations, you have all been promoted. As you present your new pipeline to the team, they mention experiencing issues with conflicting changes in merge requests when merging to the default branch because of frequent merges. You know GitLab can resolve this by queuing merge requests and comparing each one against earlier requests to ensure compatibility before merging. As a superstar, you set out to implement this solution. Look at you. So merge trains are a really powerful feature. They introduce a way to order the flow of changes into your default branch. In a fast-paced environment, when you have frequent changes to the default branch from many different development branches, this could lead to issues where while one merge is being validated, another is merged into the main branch. This subsequent merge can render the previous validation invalid. Merge trains create a queue of merge requests so that multiple developers are able to collaborate whilst keeping their default branch green. A merge train kicks off with a merge results pipeline. Remember that in lap 2, we know those run on the changes of the source and target branches combined together. The second merge train pipeline runs on the changes of both merge requests combined with the target branch, and so on and so forth for the third, fourth, etc. merge train pipelines. So merge trains, merge request pipelines, and merge results pipelines all sort of have to do with each other, and I want to clarify a couple things about them. A little bit repeating what I said in the last slide, but it can be a tough concept. So to enable merge trains, we really need all three of these features to be enabled and working. At a high level, a merge train is where merge requests are put in a queue and run on the changes of the previous merge request ahead of the queue combined with the target branch, i.e. a merged results pipeline. A merge request pipeline are run on the contents of the source branch only, ignoring the contents of the target branch. And a merged results pipeline runs on the results of the source and target branches merged together. We're now going to move on to the next section of the hands-on bit. As I said before, but I'll just show it again. You want to go to your Tanuki Racing CE to Premium workshop, go to Courses, Workshops, CE to Premium, and then we are now in the Merge Trains section. The first thing we're going to do in this section, let me change my other tab first. Let me get all situated. There we go. So the first thing we're going to do in this section is close all of the tabs that we have opened throughout the course of flailing around. Great. And then now what you're going to do is you're going to go to Build Pipeline Editor, like we did in the previous sections. And we are going to go ahead and add a workflow rule. So I believe we're supposed to have both rules. Let me double check. Yeah, they want both rules. So the final GitLab YAML should look like what's just below there. And to be honest, I am going to copy and paste that into my file just in case. I spooked myself a little. And we're going to go ahead and commit these changes. You can put a little commit message if you want. And we're going to go ahead and commit that directly to main. After doing this, pipeline should kick off. Yep, because we committed to default branch. I don't think we need to wait for it to finish, but what we can do now is we can enable merge trains. So to do that, it's similar to the previous setting we enabled for merge results pipelines. We need to go into settings, merge requests, and then hit enable merge trains. And we scroll down and click save changes. To test this, we're going to create two separate merge requests. So let's click on, let's go to code, repository, and then back to our web IDE. We are going to create a file called firstchange.md. And we don't need to put anything in it. And once we've done that, we are going to go to the source control tab, and we are not going to push to main. We are going to click the down arrow here. We're going to create a new branch, and we're going to commit to it. And then we're going to create a merge request associated with that firstchange.md file. So I create this merge request. So then we're going to go back to the web IDE. You can also open a new version of the web IDE if you want, because we are still on that branch we created. Can I go? Let's go back to main. There we go. Now that we're back in main, let's create a new file, and we'll call it secondchange.md. Once we have secondchange.md created, we go back to source control, and once again, we do not push to main. We need to create a new branch and commit, and then create a merge request associated with that. Now that we have these two merge requests, we can, second. Yeah, so now that we have these two merge requests, open them up in separate tabs so that we can look at both of them and compare. So the first thing we can do is we can set one of these to auto merge first. And this is going to be basically kicking off that first pipeline in the merge train. After this pipeline build passes, it's going to kick off the merge train. And now what we do is we can go to the second one and set to auto merge and see that it's going to say add to merge train when all merge checks passed. So that means that it's going to be the next train, so to speak, in the merge train. So once both those merge requests have been successfully merged, you can verify the changes by navigating to your repository, looking at main and checking that both files have been added. And let's start another comfort break. Now I'll go ahead and there we go. Let's put this pit stop thing up there. There we go. There we go. Okay, so let's have a 5-minute break and come back at 2:20. Oh, actually, first I'm going to show Seraphine, can you pop on the chat and or
Yeah.
pop on the mic and let me know what you want me to show?
Details. We just wanted to show you how the different MRLs will be stacked in the train. So on your screen, click on the view match train details, and then you can see that just right up where you have the widget there.
I see. Sorry. Cool. So yeah, you can see from here all of the pipelines that are participating in the merge train, and you can see which ones have already merged. Thank you, Seraphine. Appreciate that. Anyway, so back to our pit stop. We have until 2:25. And then after that, we'll run our last little poll question quickly. We could go to, yeah, let's take a 10-minute break till 2:30 on Dami's request. Okay. Hope everyone enjoyed their break. We are coming up on the last lap here. And before we start, let's go ahead and run our last poll question. Here we are. Oh, wait, not this one. We want DevOps journey question. Did the poll already launch? No? Okay. Helena, I might need some help on how to launch the poll. There we go. Is that okay? Yeah, there we go. Okay, so yeah, where are you at on your DevOps journey? Nice. So we got nice spread. We've got some in the discovery phase. Some are just starting out using continuous integration. Some have even brought in that shift left testing, which we'll talk a teeny bit about on the next section. And then we've even got some continuous delivery. Wow, someone is capturing Dora metrics. That's very cool. I wonder if that is the person attending who is already on Ultimate, because that is one of the features on our Ultimate tier. Okay, 23 answers. Give it a couple more minutes or maybe 30 more seconds. Okay, I'm going to go ahead and end the poll. Thank you everyone for participating in it. Okay, so lap 4. We are talking about reusability and security at this point. After implementing merge trains, your pipeline is running smoothly again, and word has reached the executive team. They want to ensure that all of GitLab features, such as components, security scanning, and artifacts, are being fully utilized for purpose speed and faster time to market. They've asked for you to demonstrate these features in a pipeline during the next stand-up meeting. You are thrilled to take on this task because this marks the beginning of adopting best practices such as shifting security left and centralizing workflows across the company. 1 second, sorry. I need to pull up my notes tab. There we are, back in action. So some of you may have worked with templates in the past. We have something called CI/CD components, which are sort of the kind of next step in bringing in configurable components that you can add to your pipeline. So what I really want you to think of components as are reusable single pipeline configuration units. So they're, as I say, similar to adding templates, which we are going to briefly touch on later if you're unfamiliar with. You add them with the include word the same way that you do with a template, but components have several advantages. They can be configured with input parameters for more dynamic behavior. They can be released as a true app with versioning, and they could be listed in the CI/CD catalog, which we'll talk a little bit about later. So some examples of existing components. These are in the gitlab.com component catalog. In the hands-on section, we're going to use a component created for this workshop, and then we're also going to use a secret detection component, which we pulled from the CI/CD catalog and is managed by GitLab. If this is the first time you are hearing about the CI/CD catalog, this is essentially a list of projects with published CI/CD components that you can use to extend your CI/CD workflow. It is actively maintained, or many of the components on there are actively maintained by the GitLab team. Components come in handy when you are migrating workloads. You could set them to private, which means that they'll only be visible to your assigned users within your workspace, or public, where anyone with access can view them. You can use components to create a small part of a larger pipeline, akin to building blocks. So see here how we have inputs where you could put in the specific variable arguments you need to put in for whatever the component is, as well as the stage you want it to run in, etc. We do still continue our template support. I just want to quickly touch on it. Templates are also a way to share CI/CD capabilities within your organization. We don't have a formal template catalog or anything like that. And these, as I said earlier, also use the include keyword to add them to YAML files. There are basically 4 ways that you can include an external file in your CI YAML. If you want to include a template in one of our pipelines, we use the include keyword in one of 4 ways. Either include :template, which is what you use when wanting to reference content provided by GitLab engineering department, i.e. our code quality or SAST scanners. Include :file is used to reference a YAML located in a project in the same group hierarchy as the main CI YAML you're using. So for example, when your organization has a best practice Node.js pipeline that any project could use. And then include local, which is used to reference a YAML file located within the same project or repository as the main CI YAML file you are working in. So for example, if you want to keep container setup jobs in a separate file from your build or test setup jobs, but have them execute in the same project pipeline. And then include remote, which is used to reference a YAML located in a publicly accessible project repository outside of your organization. For example, if there's a best practice template from a public community repo you want to use. Once you've included templates, though, there are ways to customize the behavior within those templates. There are a variety of ways that you can do this. We can override the default behavior of a template job by specifying keywords in a local job. So this would keep most of the job the same, but any values set specifically in the job in the local CI file override what comes from the template. Environment variables, which I'll touch on a little bit later as well, can be used to control certain behaviors with if conditions, as we saw in the previous laps, or by values set in the job controlling names. So a little bit more of a note on environment variables. GitLab has something called CI/CD variables, which we have some predefined variables as well, but CI/CD variables, you can put values into them and access them either at the group or project level. And the best practice for these is to mask and protect your CI variables for low-risk secrets. For high-risk secrets, we do not recommend that you use CI/CD variables at this time. We recommend for high-risk secrets that you are storing those in an external tool like Vault. So let's say you want to configure one of GitLab's scanners while you are on premium. I mean, to be fair, Ultimate customers can also do this, or this is also how they can implement it, or one of the ways. But if you've been paying attention, you might have noticed that you actually have access to the Ultimate tier right now, because we provisioned you an Ultimate environment, even though this is a premium workshop. We are going to configure some security scanning jobs in the next section, and if you want to get inquisitive, you are welcome to look through some of the tabs that would be how you ingest this information on Ultimate. Just to touch on it quickly, on premium, which I believe the majority of you are, if you want to be using these security scanning jobs, you are going to get the results as an artifact. It's not particularly nice for a human to read. If you specifically have no desire for any of the additional benefits like governance, I won't go on, that come with Ultimate, and you purely want to visualize the results of those scans, the best way to do that is having some sort of Python script that's just going to ingest the artifact result of your scanning job and then create yourself like a human readable HTML report. Okay. Speaking of artifacts, like I was just talking about, the result of that scanner is going to come as a build artifact. In our simple pipeline for build and tests, we already used the artifact keyword to store the dist directory, which contained the build results. Expiry is set to what the job file specifies. So in our file, we have set the artifact to expire in an hour. If you click keep within that time, you can go back later and store them manually after it was supposed to expire. Even though GitLab has a registry built in, you can also send it to artifact registries that are external, like Harbor or Artifactory. And if you don't set an expiration time in your job, then the GitLab instance level default value is going to be used, which on gitlab.com is 30 days. There's one other thing to be aware of as well. You must have the appropriate permissions to view and download artifacts. For public projects, any users with guest or higher permissions can view and download. For private projects, you need reporter permissions or greater. And there is a full table of our permissions if sorting through permissions is difficult for you. I often use it as a reference. So there are a number of ways that you can manually download these artifacts. Sometimes you just want to be able to download the artifacts related to a job. And you can do this on the pipelines page, on the jobs page, on a specific job, or in the artifact browser for a job. And in the hands-on bit of the lab, we are going to talk about that and actually do it. So with that, we are going to jump into the next set of instructions. So if you go back to your Tanuki Racing CE2 Premium Workshop project, click on Courses, Workshops, CE to Premium, Components, Artifacts, Templates, and Security. This is going to be our final section for the workshop today. So the first thing we need to do is we need to go and click into our pipeline editor. You might remember at this point how to do it, but you go to Build Pipeline Editor. And we are going to copy and paste this block of code into our pipeline. So I believe it tells us where to do it. I don't think it actually matters, so I'm just going to put this at the end. Actually, no, they want it at the top. But I believe you can just put that at the end of your file as well. So we've added 4 templates. These are all provided from GitLab. And we can actually look at the contents of these templates here. So for instance, we've got a whole YAML file here. I'm going to click into the SAST. I'm going to click into the SAST one because I want to talk a little bit about that job customization that we referred to earlier. For instance, here we have a job called SAST. This SAST job is set to run in the test stage by default. You might very well want to have your SAST job run in a different stage, in which case, if you were to be in your pipeline editor and type something like SAST stage, I don't know, build. I know we wouldn't run it in build, or maybe we run it in something called security. That is going to override the value that was in the template. I am going to remove this now before I forget about it and destroy everything. And now what we're going to do is we can also click on full configuration if we want to see the contents of our base CI file, as well as all of the contents of our included templates. There's also a visualize tab, which can be nice to show all of the possible jobs that run. These obviously aren't going to run most of the time for most projects because you are very unlikely to have a large mono repo with all of these different languages present, basically. The way our SAST scanner works is it automatically detects which languages you're using and runs the appropriate scans. Anyway, I digress. Sorry. So we've looked through the tree expanded icon. Yes, we looked at the full configuration. And we are not going to commit yet. We are actually going to add some inheritance to our pipeline. So we created, oh, I forgot that this was the next step. So I've explained exactly what happens in the next step. I guess maybe it'll be easier for everyone now. So we are going to create a new SAST job. And we're going to use it to override some of the things that were declared in the SAST template. Actually, I don't know why I'm writing this out. Sorry. So basically what this does is we're saying, hey, we actually want to run this in a stage called security rather than in test. And it doesn't need any job or stage to complete before it can start running. So this job is going to kick off as soon as the pipeline starts rather than waiting for the build phase to finish. I'm going to add an additional stage here as well. So this can be like making it so a job can just kick off as soon as the pipeline starts, even if it's in a larger stage. This can be a good method if you have sort of long running automatic testing or shift left security testing jobs that you're running, so that you could run them coinciding with the build job potentially, rather than needing to wait for the build job to succeed and then, have your security scans run. This is obviously, it all depends. There's no one true answer there, but this can be a scenario in which it's useful. And we're still not going to commit our code yet. We are going to generate and store an artifact in the next step. So we're going to stay on this page, even though it says to go to a different one. I think it's just easier to stay on the pipeline editor page. And I'm going to replace the build job with wait. Okay. Yeah, I'm going to replace the build job with this. And it hated how we did that. I think I made some changes to the project earlier, folks, and I messed up some of the tabs, so I do apologize on that. So you want your build job to look a little bit like that. You are going to need to tab in every line after this line right here. And you can tab in multiple lines at once on the pipeline editor by going, if on Mac, Command Option Shift, and then down arrow or up arrow. It'll be the same as with VS Code. Okay, and now we are going to commit. I am going to add a commit message. And in this case, we are going to be committing directly to main. Now that this is kicked off, we are going to go ahead and look at build pipelines. And then we can look at our most recently started pipeline. There we go. And this way we see the visual representation of these scans running so far. So as we can see, semgrep SAST is running in its own stage, and it kicked off at the same time as build. So now we need to wait for this to run. In my experience, this can take 2 to 3 minutes. Might take a little bit longer since we've all just kicked off our scans, but let's see. While we're waiting here, just to quickly show, if you want to look at the way you visualize these results on Ultimate, you do this from the Secure tab and then Vulnerability Report, and that'll show you the results of the scans ran on your default branch. Cool, so we've got our SAST downloaded now, or we've got our SAST ran now. And we can download this by going to the Pipelines tab, looking at the download artifacts and selecting it from here. I'm not going to download it, but you're welcome to. It's good to visualize. Again, it shows you that like the information's in there. It's not necessarily superhuman readable, but a fairly simple Python script as a job in your pipeline could make it so you have an HTML artifact that's much more easy to read. So everyone can go ahead and inspect those build artifacts if they want. And then I think once secret detection finishes, you can also look at the secret detection artifact as well. That might be available now. There we go. Secret detection. Okay. So the next step is going to be talking about components. These are very similar functionality to templates, with the biggest difference, as I said earlier, being that they can be put in the CI/CD component catalog. So to look at this, are going to go to Build Pipeline Editor, and then CI/CD Catalog, which will allow us to look at all the configurations available here. You can take some time to browse through this. There's some really interesting stuff. If you are starting out building your pipelines, I really recommend looking at reusable components like this, even if it's not from this catalog, just reusable configurations that you can use to build your pipeline so that you can reproduce it elsewhere as well. We are not first going to be adding a component from here, though. We're going to be adding a private component that Seraphine made. And to do this, let's go back to our GitLab CI YAML file. So let's just reload pipeline editor. And we are going to add it to the include stanza that we have here. So you're gonna just add it to the bottom of all those templates and see here that we are adding inputs for various variable names, which happen to be the names of certain jobs within the component. I think maybe I gave away one of the things you were supposed to think about, but forget it then maybe. The next step is we are going to remove the secret detection template that we added, which is this one right here. And we are going to replace it with a secret detection component. So by replacing it with this component, then see here how we've input the stage that we want it to run in, and we haven't had to create any new job definition or anything like that. It basically means that we can get rid of this SAST job, or no, because we didn't do a secret detection one. Never mind. So basically, we're doing the same thing as we did for this SAST job, but without having to create a new job definition. Okay. So now that you've included the secret definition or the secret detection component and job component for build, test, and security, let's go ahead and commit these changes to main. I'm going to have a commit message for it as well. And then we are going to go to build pipeline, and you'll see that the secret detection job will now run under the security stage. There we go. Beautiful. And it looks like maybe I forgot to remove the template, and that's why we have that second secret detection job. But as we are running up on time, this is where I'm going to end this section of the lab. And I'm just going to quickly go over if you want to transfer this project out of this group that we've been working on. So you should only transfer once you're done all your work, because when you transfer, you are going to lose your ultimate license. If you want to play around with looking at the security stuff, keep in this group so that you can use that ultimate license. In order to transfer your project, you're going to want to go to courses and then transfer project. And then you'll have some instructions in there for transferring your project. And with that, GitLab Premium is going to help you with faster code reviews. It's going to automate and speed up the ways in which you allow team members to bring in reviews from other team members. Our advanced CI/CD allows you to build increasingly more complex, maintain and deploy and monitor your pipelines. And the enterprise agile delivery, which we didn't really touch on, helps you plan, manage your projects, programs, and products within the integrated agile support. And now it's Q&A. Thank you, everyone. And we'll look at the Q&A questions, but I think my colleagues have been answering those as we go. Yeah, question about components versus templates. I think a lot of components, like there is a lot of parity between the two right now. There is a lot of planned work with components, and in addition, we really wanted to have something with the CI/CD component catalog where people could pick and choose the configurations they wanted to add to their work.
And to add, you can also version them out, so you can choose what version to include. I'm not sure if we have that in the templates as well, I might be wrong.
I think you can version local templates, but it's definitely not as easy as it is with components. And I haven't tried in a year, so who knows? Yeah, Christians has made a good point in the Q&A, which is if you just mention the ref, like the commit ref of the template you want to use, that is essentially versioning. I think that it's not semantic versioning, so you're not applying like a specific number to the version. But yes, you can lock in a specific template as well. So someone had a question about locking components features. I don't believe you can protect a component from changes in Premium. However, we have a concept called scan execution policies. I think they're still called that. If we go to secure policies, Um, and then create a new policy. Yeah, so scan execution policies are basically you can declare custom CI blocks or GitLab managed security scans, and basically define that these should take precedence over your base YAML file. So that would be the way to sort of protect um, from changes coming from the base CI YAML file or overriding from the base CI YAML file. And side note, policies are actually my favorite feature at GitLab. Coming from a development background, and we worked with a really, really messy system where we were committing to main a lot, and these locking things down and preventing me from actually making changes to the CI file and requiring certain jobs to run is a very valuable feature in my opinion. Anyway, I'm gonna stop sharing my screen now. It seems like not too many more questions rolling in. Oh, don't forget the survey. Okay. Um, we need to do a survey, I guess. I'm not sure how to activate the survey. Any other GitLab colleagues on this call know how to activate the survey?
There's a slide on your.
Oh, is it the next slide? Sorry. Okay, survey time. There we go. So I'm gonna share the link. And yeah, if everyone can please answer this survey, it would be very helpful for us. We really like delivering meaningful events. We really like interacting and discussing these things. It was very nice in this session. Some of the nice back and forths we had in the Q&A. It was interesting discussion. So thank you, everyone. Okay, I'm gonna go off camera. Bye, everyone. It was real fun. I think we're staying in the meeting for a bit, but I'm just going off camera.